Hi everyone, good morning. Welcome back. Can you see my screen, everyone? Yes. Can anyone confirm?
Yes, it's visible.
Yeah. So in last week we completed 3 demos, right? So introduction to DevOps, and the question and answers, and the cloud introduction, right? So those are demos from today onwards, regular sessions, right? So today, tomorrow we'll work on introduction to servers and networks, and the day after tomorrow we'll start cloud, AWS cloud. Slowly, how to create account, how to connect AWS account, what are the services available in AWS, and what are the services we use in real projects, real-time projects, and how to create infrastructure, right? So as a DevOps engineer, we have to create infrastructure, we have to maintain the infrastructure. So currently no admin roles, right? Yeah, so that is why first we need to start with cloud. Fine. Yeah, today, tomorrow we'll work on servers and networks. Yeah, so already WhatsApp group created, right? So 20 people already joined. 20 people already added into WhatsApp group. So if not added so far, you can add today itself. So 65 batch. This is our group. See here, already 20 members already joined into the group, right? Fine. So today's agenda here is what is server, types of servers, server client model and best practices, server architecture, and what is operating system, types of operating systems, what is network, types of networks, what is IP address, subnet mask, gateway, router, firewall, failover, and load balancer. So these are all very basics, right? So if you understand this, you can easily understand cloud environments. Okay. Yeah. So these are the traditional servers, traditional networks, right? Yeah. So these are very basic things, very important. Fine. So up to here we cover today. Up to here, types of operating systems. This will take 1 hour. So up to here we'll cover today. So tomorrow we'll start with network. Okay. This will take 1 hour. Fine. Yeah. So what is server? What is server? Anyone? What is server?
It's a group of applications.
It's a group of applications. Okay. Yeah. So a server is a computer that serves information to other computers. Other computers called clients can connect to a server through either a local network or a wider network such as the internet, right? So normally in real-time projects, developers, testers, DevOps engineers, every time will connect servers through network, right? So whatever code is developing by developers, they're directly developing servers only, right? Yeah. So server will have high computing power, right? CPU, hard drive, and memory, right? So centrally we can access the servers through network, either local network or wider network, or currently we are using Wi-Fi also in real-time projects. Fine. Types of servers. So these are the traditional servers: blade server, rack server, tower server, right? Yeah. So what is blade server? A blade server is a modular server that allows multiple servers to be hosted in a smaller area, right? So blade servers are very thin servers, very small servers. Enterprise level data centers we use blade servers. Okay. So these blade servers are held in one container, right? So based on the container capacity, we can insert the blades and we can configure the blade servers, right? So these are very thin. So in this blade servers, only processor or RAM available. Some blade servers will have hard drive also, right? So most of the blade servers we use external hard drive, right? Yeah. So blade servers is a modular server that allows multiple servers to be hosted in a smaller area. These servers are physically thin and typically only have CPU, memory, integrated network controllers, and sometimes storage device inbuilt. Okay, so blade servers are often seen in large data centers, enterprise level, like Google, UHG, Verizon, AT&T. So large data centers normally we use blade servers. These are high performance servers. Next one, rack servers. So rack server is a server mounted inside a rack. Rack servers are typically general purpose servers that support a broad range of applications and computing, right? So rack servers are traditional servers. Most of the data centers, most of the server rooms, we use rack servers only. Yeah, so these are the traditional servers. Yeah, so we insert a servers into a rack and we connect power network and we deploy applications, operating system, patches, right? And we can move to production. Then next one, tower server. A tower server is a computer that is built in an upright cabinet that's standalone and that is designed to function as a server. So these are a bit older servers, tower servers, right? So in one cabinet, one server. We hold one server and we connect a monitor, CPU, and keyboard to the tower server. These are a bit older servers, right? So these are the types of servers usually we see in data centers. So client server model. See here, this is the server, these are the clients, workstations like desktops or laptops, right? So when we send the request to the server through network, server will give response, right? Yeah, so normally developers, they develop the code in servers only. Through network, they connect and they develop the code, they test the code. This is another model. Even though we can connect from apps, mobiles also, right? Next one, server architecture. What is server architecture, right? Server architecture is the foundational layout or model of a server based on which a server is created and are deployed. It defines how server is designed, right? Yeah. Let's try to understand some examples here. So when we talk about server architecture, yeah. So currently we are using very advanced servers, and yeah, let's try to understand few examples here. Can you mute everyone? Yeah, server architecture, right? Yeah. So initial stage of implementation, so we can say first phase of implementation. This we can say first phase. First phase. So in 90s and early 2000, how the server architecture? 90s and early 2000, how the server architecture? So we'll try to understand. Yeah. So in 90s and early 2000, okay. For example, I want to deploy 4 packages like Java, Tomcat, Git, and Jenkins. So by the time Jenkins was not there, for example, so for understanding, we are taking Jenkins here. Yeah. So these are the applications I want to deploy on the server, right? So in 90s and early 2000, how the server architecture? Yeah. So in 90s and early 2000, when they want to deploy any packages, they used to take one separate server for every package, right? So here we have 4 packages. They used to take 4 servers. These are the 4 servers for 4 packages. Okay. Yeah. So this is these servers are, by the time 90s and early 2000, highest hard drive capacity 1 GB only, 1 GB, right? Yeah. So these are all 1 GB hard drives, 1 GB storage. Yeah. So they used to take, for 4 applications, they used to take 4 servers, right? Yeah. So here first server installed Java. So Java will take nearly, so 400 MB, for example, 400 MB. Okay. So remaining space will be wasted, right? Remaining 600 space will be wasted, right? Yeah. So here Tomcat will take 500 MB. So remaining space will be wasted. Yeah. Git will take, for example, 300 MB. So remaining 700 MB will be wasted. Right? And the next one, Jenkins. It may take 550 MB, for example. Remaining space will be wasted. Right? So they used to take each application, they used to take one server, right? Yeah. So by the time in 90s and early 2000, hardware costing is more. Yeah. So here costing is more, and applications are using less applications on each server, right? So by the time even a laptop, desktop also too much cost, right? 90s and early 2000. So by the time we used to use P1, P2, Celeron, those are the configurations, right? Yeah, so we used to spend more money for the hardware, right? So here client was getting billing was less and costing was more. That is why this model is failed concept. This concept is failed. It was not success, right? Yeah, slowly after 2000, in second phase of implementation, yeah, so they changed the model here, which is they used to take one high capacity server. In that, they used to deploy all the packages. Yeah, they used to take one high capacity server, like in this server, Java and Tomcat. Yeah, they used to take one server and they used to deploy all the packages in same server. So here what will happen? So Java user may access Java application, Tomcat user may access Tomcat application, Git user may access Git application, Jenkins user may access Jenkins application. But here there may be chances to access other application. Fine. For example, Java user may access Tomcat application also. There may be chances, right? So Tomcat user may access Git application. So Git user may access Jenkins application. So because all the users are connected to the same server, right? So there may be chances to access. Still, we have security layers available, but there may be chances to access other applications also, right? For example, so 4 people are staying in one flat. Okay, so 2 are staying in one bedroom, 2 are staying in other bedroom. Therefore, commonly access kitchen and dining, right? So the same way, so when the users are accessing the same server, there may be chances to access other applications also, right? Yeah. So here, fine. So this is one of the drawback, and also if the server is crash, so if the server is crash, what will happen? Entire all the applications will be gone, right? So this is also failed concept, failed model, right? Slowly, yeah, they move to third phase of implementation. So which is so why we are discussing about this? Yeah, currently whatever architecture we are using, whatever environments we are using, we'll try to understand. Okay. Yeah. So in third phase of implementation, so currently we are using very advanced infrastructure. That is why we are going through this. Yeah. In third phase of implementation, virtual servers, virtualization came into the market, right? Virtual servers like VMware server, Citrix, right? VMware, hypervisor, Citrix. These are all virtual layers, virtual servers, right? So in third phase of implementation, so we started working on, we started using virtual servers. So in virtual environment, how the server architecture will try to understand. So in virtual environment, what we will do? So we'll take one higher capacity physical server, Thus we can say base OS, base operating system, right? So on top of this, we deploy one layer, which is virtual layer, virtual software. So which we can say VMware or Hyper-V, hypervisor or Citrix. So these are the virtual softwares, virtual layers, right? So this virtual software will allow you to create virtual servers. So on top of this, you can create virtual servers. Yeah, so these are the virtual servers, 5 into 5, 25 servers, right? Yeah, so here we can deploy Windows, Ubuntu, CentOS, RHCL, yeah. So whatever softwares, whatever operating system you want to install, you can install on this virtual servers, right? So this virtual servers will take the resource from physical server. So whatever RAM, CPU, hard drive, right, required for this virtual servers, these servers will utilize from base operating system from here, right? So this base operating system, base server will have RAM 48 GB, highest capacity of the RAM, and a CPU 32 core. So based on the requirement, right? Hard disk, they use 10 TB like this. So these resources will be shared to the virtual servers, right? This virtual servers will take the resource from physical server, right? So different operating system we can deploy on the virtual servers. Here we have 25 servers. So we can deploy different operating system, different applications, different plugins, different patches, whatever, right? So these servers will work individual. These servers will work individual, right? So yeah. Still, we are using virtual servers in real-time projects, but here we have some drawbacks. We have some drawbacks here. What are those? So when you want to deploy operating system, so we use ISO image. So what is ISO image? What is ISO? For example, when you want to install Windows on your laptop, we use some image, right? So we copy into pen drive, we convert into bootable drive, the pen drive. So using pen drive, we can boot the laptop and we can install the operating system. The same way, yeah. So here, virtual environments, we use ISO images. ISO full form is International Standardization Organization, right? So it is a full package, full operating system package, right? So in this, all the graphics, drivers, plugins, everything will be available. Paintbrush, media player, notepad, everything is available in the ISO image. This is full package, right? So when you want to install any operating system, so minimum it would be 6 GB to 18 GB, 18 GB minimum. So we need to spend 6 to 18 GB of this space, storage space, for only operating system, right? So on top of that, again we have to install softwares, Java, Git, Maven, Jenkins, Kubernetes, whatever we require, right? Yeah, and also, for example, okay, so here we have 6 GB to 18 GB, right? So here we have 25 servers are there, 5 into 5. Or on average, each server will take 10 GB, for example, 10 into 25, 250 GB we need to spend for only operating system, right? So on top of that, we have to install packages, whatever packages required, right? Yeah. Now, so this virtual servers are physical servers. When you want to reboot, when you want to restart, so it will take 4 to 8 minutes. 4 to 8 minutes. The servers when you restart, right? Why we need to restart? So when you deploy any packages, when you deploy any code, when you deploy any applications, so we need to restart these servers. Otherwise, the changes, whatever changes you perform, those will not be reflected to the server, right? That is why once you perform any activity, you need to restart the servers, right? So 4 to 8 minutes means it is use time. Client will not accept that. That much of time, client will not accept. So when you want to restart any server, it is big challenge in real projects. In our project, so when we want to restart any servers, we need to get approval from client, management, we need to inform to respective teams, right, who are working on the servers, right? So we need to stop the databases, applications, so many roadblocks, so many challenges, right? So when you want to restart any server, we need to get all the approvals, right? Yeah, this is one more drawback. So storage utilization is, yeah, storage utilization is more, and reboot time is high, and also deployment time and downtime is high. So what is the downtime? Anyone? Downtime. Maintenance time, right? So maintenance time. Yeah. So deployment time and downtime is high, right? So when you want to deploy any packages, it will take some time. So when you want to down any server, it will take some time. That is why, yeah. So here also we have some drawbacks. So this much of time client will not wait, and also storage utilization is high, and deployment time downtime is high. So still we are using virtual servers in physical data centers, physical environments, right? Still we are using, but due to, yeah, we have some drawbacks in virtual environments also. That is why, so project teams are looking for next level, which is Docker containers. Okay, currently project teams are looking for Docker containers. So Docker containers are advanced virtual servers, right? So Docker containers, yeah, let's try to understand Docker architecture. This is advanced one. So very, yeah, currently Docker containers are very hot, right? Yeah, same as virtual servers. In Docker, we take one server, which is you can say Docker server. So it can be virtual server or cloud server. Virtual or cloud server. Even though we can take physical server also. Okay. Virtual server, cloud server, both are virtual servers. Both are virtual. Even cloud servers also virtual, right? Yeah. So it can be any server, which is a Docker server. So on top of this, we can deploy one package which is a Docker image. Docker image. So this Docker image will allow you to run containers, right? So what is container? Anyone having idea? What is container? In general, what is container?
Runtime environment.
Sorry, can you comment?
Runtime environment.
Runtime environment. Okay.
This mask is closed in a box and a wooden box.
Right. So these are all containers, right? So we can say container is a box, just like box, right? So we can move anywhere, we can use anywhere, right? So in ship, normally when you search in Docker containers in Google, you will see some ship boxes. See here. These are the ship boxes, right? So container is a box. We can move anywhere, we can use anywhere. Okay. Yeah. So these boxes are lightweight, standalone, executable program, right? It is very lightweight, standalone. They will work as a standalone. Okay. Yeah. So when I run this container, in this container, only lib and bin files will be installed. Library and binary files. Yeah. So I don't use here ISO images in Docker containers. Normally, project is not using ISO images in Docker containers, right? So not required. Full package not required. Okay. Yeah. So when I run container, it takes 200 MB only. 200 MB of this size. So when I create virtual server, it will take minimum 10 GB, right? Yeah, 6 GB or an average 10 GB, right? So but here container will take 200 MB only. Why this much of drastic change? Virtual environment GBs, right? But Docker environment MBs. Why this much of drastic change? Here, when I run container, only lib and bin files, library binary files will be installed on this container. To deploy application, to deploy WAR files or jar files or ER files, we required only minimal configuration. Minimal, right? So here, when you want to deploy applications, we don't require media player, we don't require paintbrush, we don't require notepad, we don't require graphics. It is a lightweight environment, but it is virtualization is full package. For example, so one small family, they want to live in a house, right? So what they required? 4 members, small family, father, mother, children. They want to live in one flat. What they required? They required food, bed, clothes, right? Normal living. But when they want to live lavish, they require furnishing, AC, right? So this virtual environment is lavish. This is normal living. Both are same functionality, right? Both are same functionality. Yeah. So Docker architecture, Docker containers, Docker licensing is very less costly compared with virtual and physical, right? So currently we are using online shopping, right? So online bookings, right? So when I book any product, that will be delivered within 10 minutes also because of Docker containers. Backend they configured in Docker containers. They're not using physical environment, right? So when I place order, immediately that will be placed. Within 10 minutes, the products will be delivered. Groceries, right? Or any products, within 1 hour, 2 hours, when I book any mobile or any gadgets, so within 4 hours also they're delivering because of Docker containers. Backend, they're using Docker containers. These are very faster. Okay. Yeah. Now, so when I run container, only 200 MB size it will take. And when I restart container, it will take 15 seconds only. 15 seconds. So any developer is working on the container, he may not understand. Will not understand the container is rebooted or not. It's very faster, right? And also deployment time and downtime is less, right? Yeah, deployment and downtime is less. So when you run any applications on containers, we don't require any downtime. Yeah, downtime not required, right? So lightweight environment, standalone, right? We can move anywhere, we can use anywhere. Yeah. So Docker containers are platform dependent. Sorry, platform independent. These containers are platform independent. Okay. So platform independent means, what is platform independent? Anyone? Platform. What is platform?
It
Operating
can run
system.
on any machine.
Yeah. So platform independent means Docker containers you can run on any operating system, any platform, like Windows, Linux, Solaris, even Mac OS also. So irrespective of operating systems, we can run on any platform. Okay. Yeah. For example, shell scripts, normal shell scripts. When we talk about shell scripts, only we can run on Linux, right? And also before Docker, we used to use some containers. Before Docker also, we used to use some containers, but those containers are not popular, right? So before Docker, so we used to use containers like LXC, LXC. LXC means Linux containers. Jones, Solaris containers. Next one, LMCIFY. Full form is let me container for you. These are the Google containers. So before Docker, we used to use these containers, but these are not popular. These containers are not popular because these are platform dependent. LXC will run on only Linux. Jones will run on only Solaris. LMCIFY will run on only Google, right? Yeah. So whenever Docker released in 2013, right? Yeah. So from 2013, online shoppings increased, right? So irrespective of operating system, we can run on any platform. This Docker containers, Windows, Linux, Solaris, macOS, everywhere, right? We can move anywhere, we can use anywhere. Fine. Yeah. So Docker is very hot currently. Docker containers are very hot. So if you understand Docker, if you can easily understand Kubernetes also. Kubernetes is very advanced Docker, right? Yeah, currently Docker Kubernetes. If you understand Docker Kubernetes, you can easily crack your interviews. Docker Kubernetes. These are very core tools, advanced tools, right? So in DevOps, we have multiple tools are there, right? So we are going to learn 12 tools nearly, but Docker Kubernetes are, these two are most important tools. Okay, you can focus on Docker and Kubernetes. Fine. Any questions up to here, anyone?
We have an option of moving this virtual environment to cloud, right?
You can migrate the applications.
Not migrating. We can consider here, right? In this option, we have a cloud to use it. Any limitations with the cloud? That's what you are moving to the from virtual environment to. So what is the limitations with the cloud?
Limitations.
Because in this scenario, we can consider cloud application, cloud service. Why we ignoring cloud in this option? So any limitations with the cloud? Because if you take deployment on downtime, if we deploy application in the cloud, downtime, deployment and downtime will take less time only. Still, we have ignored that option. We are moving to Docker. Any reason?
Okay. Yeah. So limitations means, so as like Docker thumb rule, right? So when you migrate, you want to migrate or you want to?
Not migrating.
Ah.
So you have explained server.
Right.
In the third phase of implementation, virtual server came into the picture.
Right.
And it makes our lives easy. Okay. So after that, we have an option of cloud. So where whatever we have limitations in virtual environment, that will be covered in cloud, right? So if you take deployment and downtime, in the virtual environment, its downtime is very high. But in the cloud, it will take less downtime only.
Right. Not cloud, in Docker.
Okay. So in cloud, deployment downtime is less only compared to virtual environment. So we have an option of moving whatever the applications in VM to cloud, but still we are ignoring that option and we are moving to Docker. So any reason for ignoring the cloud here?
Yeah. So because main reason is time saving, cost saving. Main reason, time saving, cost saving. That is why, yeah, project teams are looking for Docker architecture, Docker containers. Main reason, time. Time is most important, right? And cost. Client always look for the cost.
So still cloud servers also will take higher downtime.
Cloud servers also normal virtual servers, those are. But in Docker environment, I'm talking about Docker. In Docker, if you host any applications, so we don't require downtime. Okay. So Kubernetes, Docker, those are highly scalable infrastructure. Scalable infrastructure, no downtime, no deployment.
So whether we are deploying these Docker servers in the cloud?
Yeah, cloud only. Yes, cloud only. So most of the project teams, they are using cloud only. Okay. So any other questions, online guys? Anyone having any questions?
How is this significant to Kubernetes?
Kubernetes, right? Yeah. So Kubernetes is advanced to Docker. So we'll discuss that. Okay, while working on Kubernetes. So we'll go deep dive. Yeah. So in Kubernetes also we use Docker containers. Without Docker, Kubernetes will not work. Docker released in 2013. Immediately after 1 year, Kubernetes released 2014. So because Docker also having some drawbacks. Okay, that is why Kubernetes released in 2014. Yeah, so Docker is having some drawbacks like configuring clusters and maintaining cluster is a bit difficult in Docker. But in Kubernetes, configuring cluster, maintaining cluster is very simple, very easier. Okay, and also Docker supports 95,000 containers. Docker supports. Kubernetes supports 3 lakh containers. Some differences are. Okay.
Okay.
Yeah. So we'll go deep dive while working on Kubernetes. Fine. Clear, right, everyone? So this is a very advanced one. Yeah. Currently, most of the project teams, they are migrating to Docker architecture, Docker containers. So whatever applications, whatever operating systems we are hosting on virtual environments, so currently we are hosting on Docker containers because of lightweight. Okay. Fine. So server architecture, this is server architecture. We'll go deep dive while working on cloud server architecture. Okay. Yeah. Next one, what is operating system? What is operating system? Anyone? What is operating system? So computer hardware always understand binaries 000, 001, 100, 111. So hardware will understand binary language, but human will not understand binary languages, right? That is why we required one translator, mediator, which is nothing but operating system, right? So computers hardware will understand only binary language. See here. So operating system is an interface between user and the computer hardware. The hardware of the computer cannot understand the human readable language as it works on binaries, that is zeros and ones. In such case, we need an interface which can translate human language to hardware and vice versa for effective communication. It is an interface, it is a mediator. See here. So hardware, operating system, and user, right? So operating system will convert into binary language to human readable language and vice versa. Next one, types of operating systems. What are the types available? Single user, single tasking operating system. So in this type of operating system, one user can log into the system, he can perform only one task at a time, which is nothing but single user, single tasking operating system. For example, MS-DOS, Microsoft Data Operating System. So in this type of operating system, only one user can log into the system, he can perform only one task at a time, right? Yeah. Next one, single user multitasking operating system. So in this type of operating system, one user can log into the system, he can perform multiple tasks at a time, right? Which is nothing but Windows, for example. So while browsing internet, while working on any activity, we can run background audios, right? So multiple tasks you can perform at a time. Next one, multi-user multitasking operating system. What is this? So multiple users can log into the system, they can perform multiple tasks at a time, which is nothing but Linux. For example, while deploying the application, while deploying the code, so multiple users can log into the servers like developers, testers, DevOps engineers, build and release engineers, everyone can log into the servers. They can perform their own activities, right? So multiple users can log into systems, they can perform multiple tasks at a time, which is nothing but multi-user multitasking operating system. So currently, most of the project teams, they are using backend servers. They are using Linux only, right? So we are using Windows also, but very few servers. Why Linux? What is the importance here? Why Linux? What is the importance here? What is the difference between Windows and Linux? Anyone? So Linux is command line, right? Windows is GUI, graphical user interface. So when we compare with the GUI, command line is more secure, right? So command line is more secure. So when any virus is released, any threats released, directly attack to the Windows first. But Linux is more secure, right? So most of the data centers, most of the physical or virtual, or most of the project teams, they are using Linux only production servers, because Linux is stable and also, yeah, very faster, no costly repairs, right? No slowdown issues, no crashes in Linux. Okay. So in our project, we are using Windows servers also. Most of the servers Linux only in our data center and cloud data center also. So very few servers we are using Windows. Okay. So one of the Windows server is having Windows 2012 R2 operating system. So the server was giving high CPU. The server was having some issues. High CPU utilization. High CPU utilization. High CPU means, yeah, CPU utilizing 100%. So if the server is utilizing 100% CPU utilization, so whatever application is running on the server, that will be impacted. That will not be accessible, right? Yeah. So whenever we got that issue, whenever we face that issue, we raise the case with the Dell vendor. Server is Dell server. We raise the case with Dell vendor. Dell vendor visited our data center. They check the server hardware. They conclude that this is not hardware issue. This is operating system issue. Okay. So by the time we raise a case with Microsoft. Okay. So Microsoft team asked us to provide all the logs. Microsoft team asked us to provide all the logs, right? System logs, app logs, every logs. So we provided all the logs. Once we provide the logs, they analyze that they took nearly 2 weeks time, and they conclude that this is one of the patch issue. Patch. So Microsoft releases monthly patches, right? What is patch, anyone? What is patch, anyone?
Updates.
Okay.
Updates, right? System updates. So in our Android mobile, you get updates, right? We install updates. The same way, server side also we get some updates. Okay, that we have to install, because so if you don't install that, the applications, whatever latest applications we are using, those will not work properly, right? So that is why whatever updates we receive, that we have to install monthly basis, right? Yeah. So Microsoft team conclude that this is one of the patch issue. By the time we check that, so one of our engineer, so instead of installing proper patch, they installed different patch. That is why server was taking high CPU utilization and a slowdown, right? So many issues. So by the time, yeah, as advised by Microsoft, we removed that patch, installed proper patch. That was working well. But for that resolution, they charged $2,500. Costly repairs. Windows is costly repairs, slowdowns, crashes, right? Yeah. So, but Linux, not like that. Linux will not have any slowdown issues, no crashes, no costly repairs, right? So these are the differences. That is why most of the production environments, most of the production servers, we are using Linux only, right? So in our course, we are going to learn Linux, Linux architecture, Linux folder structure, Linux origins, right? Linux basic commands, advanced commands, deployment commands, and user management, right? So nearly 40 commands required that we are going to learn once complete the AWS, right? So these are the things. So networking we'll discuss tomorrow. We'll start tomorrow, right? So coming 3 to 4 days, only 1 hour session, right? Yeah. After that, once we enter into the cloud, once we start working on services, cloud services, it would be 1.5 hour daily. Fine. So any questions, anyone? So anyone newly joined today, online guys, you can WhatsApp me or call me. I provide you demo links, demo videos. Okay. So my mobile number is 96422 11711. This is my personal number. You can take down and you can WhatsApp me, call me for videos, previous videos. I provide you all the videos. Anyone joined newly today, can you provide your WhatsApp number and email address so that we'll add into some broadcast group? Anyone newly joined today? Yeah. Fine. So tomorrow we'll work on networking basics, which are very, very important. So if you understand these basics, you can easily understand cloud environments, right? So tomorrow's session is also very important. Yeah, don't miss the session. So if you are not added into WhatsApp group, you can make the fee by today. So the fee would be 20K, 20,000, right? Yeah. So you can make the fee today and you can forward the screenshot to me so that I'll add into WhatsApp group if you are interested. Okay. Any questions, anyone? I'll provide you course content. If anyone required, you can WhatsApp me, you can call me. And this recording sessions also, I provide you. Fine. So classroom is pending. So if you're interested, you can make the feedback today. Okay. right? So maybe meeting link will be changed tomorrow, right? Online guys, you cannot join from tomorrow, right? So today our people are allowed to join, but maybe tomorrow the meeting link will be changed so that you cannot join. That is why if you are interested, you can make the feedback today so that you will be added into WhatsApp group. You will get all the recordings, all the documents and contents, right? Yeah, so we stop here. Yeah, tomorrow we'll continue. So networking concepts. So day after tomorrow we'll start cloud. Fine. Yeah, so we stop here. Yeah. Thank you all.
Thank you.
Thank you.